Welcome children in my channel Ncert Physics. Now I am giving again revision for motion and force. Now what is the topic I am going to revise you? That is the basic question that I am discussing with you, that concept on graph. Now I am showing you some big graphs. Suppose this is the time, this is the displacement. If this graph is parallel, it means this graph means body, the body at rest, the body at rest. If the displacement graph parallel to time axis, this is the time, this is the displacement. So whatever the time may be, displacement always constant, that means body is rest. Now another graph I am showing you. This means with time velocity does not change. With time velocity constant. This is the graph number 2. This is the graph number 2. Velocity constant. It is a displacement 0, then body at rest. Now this is the graph. Means this is V, this is U, this is the time. So t equal to 0, there is initial velocity, the body moving with initial velocity U, final V, final velocity V. So this is another graph. Area of this graph will give you, the displacement. Another graph, this is graph number 3. I am showing you another graph. Now x and t, this is V. This graph represent V equal to constant. In this graph, that means tan theta, this is theta, tan theta constant, that means uniform velocity. Now similarly, if this is the graph t and this is v, that uniform acceleration, that is mean uniform acceleration. So many graphs I am showing you. First, if the displacement parallel to time, then it is rest. If v parallel to time, that is velocity constant. If displacement and time slope is constant, then v constant. If v, this slope is constant, then uniform acceleration. But if slope changes, so this is the general graph. I am just removing first one and showing another graph. Suppose this is this graph, this is v and this is t, non-uniform acceleration, because every point slope is changing. Non-uniform acceleration, non-uniform. So any graph you may get non-uniform acceleration. Similarly, slope if negative, then it is retardation. If slope is tan theta, then slope positive. If slope is negative in that way, then it is retardation. So non-uniform acceleration. Now if slope is like this, that means slope is like this, then non-uniform retardation. So first question, concept of graph I am giving you. Now slope of VT graph will give you acceleration, area of VT graph will give you displacement. Now I am removing. Many graph I have discussed with you. Now another question, if a body initial velocity, answer number 2, answer 2, initial velocity u, final velocity v, average velocity u plus v by 2. Now displacement is equal to average velocity into time, that is equal to s equal to, instead of v you write down u plus at, because you know by 2 into t, that is equal to s equal to ut plus half at square. Now from the definition of acceleration a equal to v minus u by t or v equal to u plus at, you know. So this is the by method you can calculate s equal to ut plus half at square. Already I have done s equal to ut plus half at square. Why I am giving trace on these two chapters in mechanics? This is the very important two chapters, motion and equation of motion and force, concept of force. So many numericals can be obtained from this chapter. So 2 or 3 more classes I shall take. After that I shall start gravitation. You follow. Now this is the topic. Another way you can do, if there is a graph U, this is V, then area will give area equal to S, that equal to half sum of the parallel sides trapezium into T. It is coming S equal to ut plus half at square. So by graphical method you can prove this. S equal to ut plus half at square. So one formula you obtain, S equal to ut plus half at square, I am removing. Next, with the help of this, so one equation already you have got, S equal to ut plus half at square. Equation number 1. Then from Newton's chapter, first law I am giving you. According to what is the law? First question, what is the law? Law means in absence of force, the body either will be rest, body rest or motion with v constant. Now body either will be rest or in motion with constant velocity move in a straight line. In absence of the force, the body either will be rest or in motion with uniform velocity in a straight line. Now the tendency of a body to be a rest known as inertia of rest. Now I am giving you inertia of rest. Already inertia of rest, it means an inertia of motion. There is two type of inertia of motion. Another one is inertia of direction. Now give example. Already suppose you are riding a horse. Horse is moving uniformly with uniform velocity. All of a sudden horse moves. Then you will lean backward, because lower portion of the horse will move with the horse, upper portion having the tendency to be a rest, so it will lean backward. Similarly, if you suppose this is a string, heavy load you are hanging, and there is another string. Now if A and B, if you jerk, then it will cut at the point A. If slowly pull the string, then it will cut at B, because when you are always sudden jerking, then M body, massive body having the tendency to be a rest, so this force will not be communicated at the point B. But slowly if you apply force, then this force will be applicable at the point B also. So this is the inertia rest. So many example you could give. Now another example is carpet. If you jerk a carpet, then dust particle having the tendency to be rest and carpet is vibrating, so there will be dust particle gets separated easily from the carpet. So many example is given. Similarly, inertia motion. Suppose in a horse is moving, your rider is also moving in the horse. All of a sudden, horse stops. Then lower portion comes to rest, and upper portion having the tendency to move forward. As a result, the rider will lean forward direction. Similarly, a fan. As soon as you switch off the fan is not coming to rest because due to inertial motion, fan having the tendency to move. Similarly, athlete runs before long jump, they run certain distance because they captures inertial motion, so that muscle effort will increase for maximum jumping range. Similarly, running train, when you are coming down, then what will you observe? That you are leaning forward direction, because as soon as you are coming down, your lower portion coming to rest, but upper portion having the tendency to be in motion, so you will lean forward. Now I am coming the inertia of direction. Now already I have shown when in a mud, when a cycle wheel moving, then we observe the mud is moving tangentially to the wheel of the cycle. Or you are sharpening the knife, then spark we observe moving tangentially. Or you are rotating a body in a circular path, all of a sudden the spring breaks, then the body will fly tangentially, because in that case centripetal force will stop. So many example I am giving you inertia direction. Suppose a helicopter moving up, a food packet is released from the moving helicopter, then packet will have, due to inertia direction, packet will move up, then under gravity it will fall down again. So you do. Now my question is that Newton's first law you state, inertia depends on mass, you do, and similarly inertia of rest write down some example, and inertia of motion there are some example, this you do. So this is the inertia first law. In Newton's first law gives the idea of the force. Force is a physical vector quantity which acts on the body to change the state of its motion, either from rest to motion or motion to rest. It may be push or it may be pull. Okay, next I am teaching you second law. Before going to second law, I am going to tell you that second law, before going to Newton's second law, very important, because numerically you are measuring second law. According to second law, rate of change of momentum equal to force. Force equal to proportional to rate of change of momentum, and momentum change takes place along the direction of the force. Rate of change of momentum proportional to force, and force, this rate of change of momentum takes place along the direction of force. Now force into time, that is the change of momentum, it is called impulse. Now from this equation, if you put F equal to some constant k, m, v minus u by t, that is acceleration. For unit force, F equal to 1, m equal to 1 and a equal to 1. Unit force is that amount of force which acting on unit mass causes acceleration 1. So in that case you are getting F equal to ma. Now this is the formula for Newton's second law. So to capture force, what will you do? Mass and acceleration. Whenever force, unbalanced force acting on the system will be accelerated. SI unit of force is Newton, 1 Newton, and CGS unit is dyne. Now this force and time of action of force is known as impulse. Impulse is the change in momentum. So always remember, if momentum change you calculate, and if you divide the momentum change by time, then you are getting the force. Force equal to change in momentum by change of time. So this is the force, change of momentum by time. So whenever you are going to calculate force, first to calculate the change in momentum and divided the time for change of momentum, you are getting force. So this is another equation you are getting, 2 P equal to ma. Clear? So this is the second equation. After that I am giving you concept on inertial and non-inertial frame and pseudo force. Very important. So again I am telling second law. Second law gives you the numerical value of the force. Force equal to mass into acceleration. Yes, from second law you are getting the concept of impulse and impulsive force. Impulsive force is the huge amount of force acting for a very short period. As for example, you are striking a ball with a bat. Striking time is very less, but there is a huge change of momentum for the ball. Similarly, hammer. When you are hammering a nail, there is a time of contact between hammer and nail is very minimum, but there is a huge change of momentum of the nail as you strike the nail by hammer. Now, this concept is very important. So, from Newton's second law, you can calculate easily force when mass and acceleration is known to you. Now, I am giving you inertial and non-inertial frame that I have done in Newton's first law, and this is the law. Now there is a two frame. Frame are two types. One is inertial, other is non-inertial. Or you can take this inertial frame is velocity equal to 0 or velocity constant, and Newton's laws are valid. All Newton's three laws are valid in inertial frame. Non-inertial frame is accelerated frame. Accelerated frame. Example, I am giving you. You are moving in a car moving in a circular path, then you are experiencing a force backwardly, outwardly you are experiencing force. This is known as centrifugal force, and this known as not it is a reaction force, it is a centrifugal force, it is a pseudo force. Really this force does not exist. We experience this type of force, that is pseudo force. As for example I am giving you, suppose this is the body A, B is another body on A, two blocks. A is another one block. Now A is moving towards east, A moving, then B will move towards west due to pseudo force. If there is acceleration of A along towards east, then pseudo acceleration of B just reverse direction it will act, that is a pseudo acceleration. So in accelerated frame, when a lift, suppose a lift, I should do it in a class, if a lift moves up or lift is moving down with acceleration, then this system is known as a non-inertial frame. In that case also we are getting some pseudo concept force, pseudo force. Now again I am concept of pseudo force is applicable only non-inertial frame, which is accelerated frame. Suppose you are in a car, you are moving in a circular path, then due to a pseudo force on your body outwardly another force is acting. And death trap game, in fear you have seen the car is moving in a circular path, then due to that a pseudo centrifugal force, it is attached to the wall of the death trap. Now I am giving some example. This concept, so today in our class, first I am using S equal to ut half at square. One problem I am giving you. Suppose you are throwing a body upward. You are throwing a body upward. It attains height 80 meter. If acceleration due to gravity g 10 meter per square, what is the initial velocity? What is the initial velocity? Interesting. You are throwing a body. Problem number 1. You are throwing a body upward. It attains height 80 meter against gravity. Acceleration due to gravity 10 meter per second square. What is the initial velocity? Which formula must use? S height h equal to u. This formula you are not using. You are using suppose at the highest point you are throwing with velocity u, at the top point v equal to 0, because when you are throwing a body upward, velocity at the top point v will be 0. So you are getting v square equal to u square minus 2gh. From that equation v equal to 0 at the top point, you don't know, g if you put all, then you are getting u square equal to 2gh or u equal to root over 2gh. That I shall solve. V square equal to use this formula. I think you have done u square minus 2gh. That means you are getting v square equal to u square. Why minus? Because your gravity is acting downward and your motion is upward, so it will be acceleration due to gravity. So it is coming to 10 and 80. So 40 meter per second answer. If this again I am telling, you are throwing a body upward, at the top point velocity 0, the final velocity known, initial velocity you have to obtain. Relationship between, you already know, v square equal to u square plus 2as. Already you have done. But when under gravity you are moving, a will be g and against the gravity mean minus. So this formula is used. Clear? This sum you may very interesting. Clear? You are throwing a body upward, it attains the height 8 meter, g at 10 meter per second square. What is the initial velocity by which you have thrown the body? Now v square equal to u square minus 2gh. You may ask me why v0, because at the top point velocity is 0 and at the you don't know in the formula, g 10 and h is 80, attained by the body 80, so we are getting calculating 40 meter per second. That means if you throw the body 40 meter per second upward against the gravity, then after moving up 80 meter the velocity will become 0. Next problem I am using f equal to ma. Now this problem I am solving you. Suppose problem is given like this: 60 Newton force acts on 10 kg mass at rest. At rest. Problem number 2. At rest. Calculate acceleration. Calculate acceleration. Why this is very important? Jointly you read this chapter. All children jointly calculate acceleration. Number 2. Final velocity. Final velocity after t equal to 2 seconds. So what will you do? Force F equal to 60, mass equal to 10 kg. So you know acceleration you will obtain force by mass 60 by 10. You are getting 6 meter per second square. This is the acceleration. Which formula you are using? You are using P force equal to mass into acceleration. Already you have done. Once you know the acceleration, final velocity you have to calculate. You know v equal to u plus at. Already from equation of motion you know v equal to u plus at. So v u0, a acceleration already of 6, time is given 2. So body will attain 12 meter per second velocity. Again I am telling, this is very important sum. 60 Newton force acting on 10 kg mass at rest. Calculate acceleration. What will do? Force divided by mass, you are getting acceleration. Now use v, final velocity you are going to calculate. When you know acceleration, how to calculate final velocity? First to see final velocity v. acceleration A known, final velocity have to obtain, T is given. So relationship V equal to U plus AT, U equal to 0, body is rest. U equal to 0 because body is at rest. Okay. Now this is the first question. Now there are another basic concept on pseudo force. You will do numericals next class. Pseudo force. Pseudo force always act along the opposite to the direction of the mother force. Suppose a body moving with acceleration coming down, they on a string, then a pseudo acceleration will act upward direction. Suppose a body with a acceleration coming down, it is positive, then it will be negative acceleration will act on the string upward direction. So in this way we shall calculate so many numericals. From next class you follow. Every class I am doing some theoretical part at the same time some numerical first, because in physics if you are strong theory and numericals parallelly if you do, then your concept will be better. Now children, if you think this channel is helping you, you are getting benefit from my channel CHAP9 Physics, then you subscribe my channel and cooperate with me. Thank you. Good night.